In the section on P-file, we saw how to use domain knowledge to classify malware and benign samples. In this section, we're going to see how we can classify malware with no domain knowledge. The technique we're going to use is called n-grams. What are n-grams? In standard quantitative analysis of text, n-grams are basically just sequences of n words or characters or tokens, this depends on your application, that you extract from the text. For example, let's say you have the traditional text, the quick brown fox jumped over the lazy dog. Then your 1 grams are just the words, the quick brown fox, and so on. Your 2 grams are going to be consecutive pairs of words. The quick brown, brown fox, fox jumped, and so on. Your 3 grams are going to be consecutive 3 words. The quick brown fox, brown fox jumped. So what are these n-grams good for? Well, surprisingly, n-grams capture a huge amount of local statistical information. One application of these n-grams, for instance, is constructing a Markov chain and then using this Markov chain to generate new text. For instance, I can feed in Shakespearean text into my Markov chain and then use it to generate new Shakespeare-like text. Here's one such artificially generated Shakespearean text. And it looks very much like Shakespeare if you look at it sentence by sentence. But if you look at it globally, then it will make no sense at all. That's because you've captured the local statistics of the text, but not the global ones. From our standpoint, we're going to use these statistics of n-grams to classify malware. Our plan is as follows. We're going to look at the byte sequence of each one of our samples. It's going to look something like this. This is a little snippet. You see here that on the very left, there is an address. We don't really care about that. And then there is a sequence of hex number pairs, F3, FF, 64, and so on. Those will be our words. We will need to figure out the best n because the best n depends on the application. Conceptually speaking, when n is really small, we don't really capture much of the local statistics. When n is really big, we will be overfitting to the text. We'll be capturing too much information that is unique to the samples we are looking at and will not generalize. We will also need to figure out which of these n-grams are actually useful and which ones to discard. The number of n-grams grows exponentially. This causes both a problem in terms of storage, in terms of computational time, and also can decrease the accuracy of our classifier. So we're going to use some techniques to figure out which n-grams are actually good for us. Finally, once we have settled on the n-grams that we want, we'll then build a classifier that will use the n-gram counts as our features and predict malware.